Hi, thanks for joining me. Today we're going to be talking about space exploration for the sixth grade student. So, about 1950, there started being a lot of advances, but before then, you could really only use a telescope to explore space, and that was thanks to Galilei in 1610. You can go ahead and fill those in if you've printed your guided practice to do with me. He gave the world a more modern telescope to better observe the moon, prove sun was the center of the solar system, and discovered several of Jupiter's 79 moons. Awesome. By the way, I couldn't let it go without telling you a little bit of the background of this story. His discoveries got him arrested and forced to say he was lying because they all thought the Earth was the center of the solar system. So when they looked up, they would see that the sun would rise in the east and set in the west. So it looked like the sun was orbiting us. But that's the same as thinking that when you're at the stop sign and you move away in your car, you'll see the stop sign move. But it just appears to move. That's just you, boo. Obviously, our brain knows that the stop sign didn't grow legs and run away from us. It's us that's moving. And that took a little convincing for Galilei and Copernicus before him to say, it only looks like it's moving. We're spinning. Anyway, fast forward 100 years, the people that got him arrested, they kind of went, oops, okay, we agree. And they went from there. But let's jump a little ahead. Let's go beyond telescopes. So from the 1950s on, technology had finally advanced enough that scientists and engineers around the world innovated suits, tools, vehicles, rockets, and spaceships. However, we do have a very annoying oxygen habit that makes it hard to get into space. And we have to fight Earth's very strong gravity in order to get to space. So these were major hurdles to overcome. And we're still working on it. So more often we'll use unmanned vehicles, as in they don't carry humans aboard. They're just like robots, kind of. And so they'll use satellites, rovers, and probes. Satellites are just going to orbit Earth. Rovers are actually made to land on like the moon or Mars. And then probes are usually sent out in space, and sometimes they just orbit one particular planet, and sometimes they're just shooting off in one particular direction. So it's kind of cool. And then we had a big jump in 1998. The International Space Station, or they like to say ISS, began construction. It orbits Earth, and it has space crews from all kinds of countries that come do research. In fact, in 2012, they opened it up to regular people to visit space for major money. I tried to look it up, but I don't even think I had enough money to look it up. So here's the ISS. It's about the size of a football field, and it weighs 450 tons. Ugh. So look at this poster over here. It just has some comparisons for you. So the top right is the actual size of the International Space Station, and then they made everything else to scale to fit it. So you can see, like, right below it, it's about the size of a football field. Seems a bit larger than the Statue of Liberty. Not quite as long as the Titanic in blue below it, but you can see it's definitely bigger than a plane. So I kind of thought that was a neat comparison. So, space is big, yo. Just to show you, a probe that left in 1977 called Voyager 2 has been traveling for over 40 years. And it's gotten some awesome pictures to send us of Jupiter, Neptune, Uranus, and all those in between. And it finally got close enough to see some cool pictures of little Pluto, but it's kind of looking ahead. But I wanted to show you, if you look at Earth in my picture, it's only gotten from here to here in 40 years. So it's going to take a long time to even officially be all the way out of our solar system. And it's considered right now to be on the edge of our solar system. So that's a lot. Here's the deal. We can travel really fast, but not fast enough. So if we're going to have a person on board, then we're going to need a lot of food and a lot of oxygen, and we can't go as fast because we're way heavier. But if it's unmanned, no person on board, then we don't need food and we don't need oxygen. And it can actually travel 400,000 miles per hour, this little probe can. It doesn't always travel that fast. It depends on, space dust and stuff like that. But just to show you, that's 400,000 miles per hour. Now, if we could travel as fast as light and energy waves, they both travel at 180,000 miles per second. If I put that back into hours, like we have up there, miles per hour, that's 600 million miles per hour. Nowhere near that speed, okay? Now, let's say if we do bring people, a modern spacecraft with people and supplies, it can get up to 30,000 miles per hour. That's no joke. That's 9 times faster than a rifle bullet. But it doesn't help us much, okay? Even the probe going 400,000 miles an hour, look how long it would take to reach our next closest star. Our next closest star is called Proxima Centauri, and it would take us 73,000 years to reach our next closest star, and that is booking it. It is speeding along, 400,000 miles per hour, but it's still going to take 73,000 years to reach. So space is big, and that's why we haven't traveled as much. I wanted to show you some really cool names in space, but I have to tell you I'm doing a disservice to the ones I didn't mention. But I just wanted to kind of hit a very few so you could see. So I put them in order of year. So we start with Yuri Gagarin. He was a Russian, and he was the first man to orbit Earth. That was 1961. And then we have Valentina Tereshkova in 1963. She was the first woman to orbit Earth. And then Robert Lawrence in 1967 was our first black astronaut. Just a couple years later, Neil Armstrong and Buzz Aldrin were the first men to walk on the moon in 1969. And then Sally Ride, 1978, was the first U.S. woman in space. And Mae Jemison, my personal favorite, 1992, was the first black woman in space. Every single astronaut and person in the space program contributed their own thing, especially if you've ever seen Hidden Figures. I mean, there are so many contributions, and they all worked together. So there's like 100 other awesome names. Please look into it and look up these people and keep their names alive if you're interested. All right, so what about next? Space bases are the current thing that they're looking to try to tackle. Most scientists would like to be able to make long-term visits to space with a permanent base or a launch pad on the moon or perhaps Mars. A trip to Mars in a spaceship takes 8 months. But that's if we don't bring any food or oxygen other than for the trip. What are we going to do once we get there? Do we bring our own goodies separately? Do we try to get what we need from Mars's resources? We need a lot of help, so I can't wait to see what your generation does with space exploration in the future. All right, thanks for joining me. Bye.